Assalamu alaikum. So we are starting with the testing of population mean with an unknown population standard deviation. In previous lecture, we already learned about the formula and its procedure for testing a hypothesis for unknown population standard deviation. So let's start with this example. The current rate for producing 5 AMP fuses at Neary Electric Co is 250 per hour. So there is a machine which produced 250 pieces per hour. A machine has been purchased and installed. According to the supplier, will increase the production rate. So supplier suggested that if they install a new machine, so they will get the increase in production rate. So this is the information which will be stated in alternative hypothesis. A sample of 10 randomly selected hours from last month revealed the mean hourly production on the new machine is 256 units. So new machine will produce 256 unit with the sample standard deviation of 6 per hour. So this is the information at the 5% significance level. Can Neary conclude that the new machine is faster? So there is a 5% significance level that Neary will install a new machine, and that new machine will have a efficient production. So moving on to the next slide. So step 1, state the null and alternate hypothesis. So this information was given into the statement of the question, and this is the H0. So whatever the H1 or H0 is, so both will be opposite to each other. Step 2, select the level of significance. So it is the 0.05, which is 5%. Step 3, find a test statistic. Use the t distribution because the population standard deviation is not known. So why we are using t distribution? Because population standard deviation is unknown and sample size is less than 30. If population standard deviation is given, so at that stage we are going to use the z statistics. So now here we are going to state the decision rule. There are 10 minus 1 is equal to 9 degrees of freedom. So what is the degrees of freedom? Degrees of freedom is actually the number of numerical values at the final calculation. So this is n minus 1. We have n hours. The null hypothesis is rejected if t is greater than 1.833. So this 1.833 is a critical value. This critical value is taken from the table. So we will put the data into the formula. Sample mean minus population mean divided by standard error. This is the formula for standard error when we are using t statistic. So at that point, standard error is equal to s divided by under root n. In case of z, standard error is sigma divided by under root n. So the divisor of this formula is basically standard error. Calculated value is 3.162, which is greater than 1.833. So we will reject the null hypothesis. The mean number of produced is more than 250 per hour. So the machine has a faster production rate. So let's move on to the next slide. Tests concerning proportion. So we are going to see that how we can test the hypothesis when we have the information in percentages or fraction. Proportion is a fraction or a percentage that indicate the part of population or sample having a particular trait of interest. So this is the definition for the proportion. The sample proportion is denoted by P and found by X over N. So this X is basically number of successes divided by number of trials. The test statistics is computed as follows. Test of hypothesis, 1 proportion. So we are here finding out the proportion for one population. This is the sample proportion. This symbol is denoting the population proportion, and this is the standard error for proportion. So this is the formula for standard error. So let's move on to the next slide. So assumptions in testing a population proportion using Z distribution. So here we are talking about the number of trials and number of successes. If you have remembered the binomial distribution, which we have discussed in chapter 6. So a random sample is chosen from the population. It means we draw a sample from the big population. It is assumed that the binomial assumption discussed in chapter 6. So if you want to revise the binomial assumptions, so you can take a brief review of chapter 6. The sample data collected are the result of counts. So we are counting the number of experiments. So we can get the n value. The outcome of an experiment classified into one of two mutually exclusive categories. So if we are going to, if we flip a coin, so there will be half chance of getting success or a half chance of getting failure. So these are two possible outcomes, and these two outcomes have an equal chance to be occur. The probability of success is the same for each trial. So this is the same thing which I have already discussed. And trials are independent. So trials do not depend on each other. The test we will conduct shortly is appropriate when n into sample proportion, population proportion, and n into 1 minus population proportion are at least 5. So this is the formula for mean proportion, and this is the variance proportion. So these two estimation must be greater than 5. When the above conditions are met, the normal distribution be used as an approximation to binomial distribution. So if this condition is met, so we can use normal distribution other than the binomial distribution. So moving on to the next slide. Here is the test statistic for testing a single population proportion. Z is equal to sample proportion minus hypothesized population proportion divided by standard errors. This is the proportions standard error formula. Population proportion into 1 minus population proportion divided by n under root. So we will use this formula in next example. So test statistic for testing a single proportion, a population proportion example. Suppose prior election in a certain state indicated it is necessary for a candidate for governor to receive at least 80% of votes. So here we have the percentage or a trait which in which we are interested to find out that we are test the hypothesis. At least 80% of the vote in a northern section of the state to be elected. The incumbent governor is interested in assessing his chances of returning to office and plans to conduct a survey of n registered voters. So this is the n 2000 value of n. 0.8 is basically the population proportion. Using the hypothesis procedure, assess the governor's chances of selection. So we are actually assessing the re-election of the governors. So level of significance is 5%. So now step 1, state the null hypothesis and alternate hypothesis. So which were the keyword? Keyword was the at least, and which is stated into H naught, because at least, at most, these two words have the equality sign, and the H1 is exactly opposite to H naught. Step 2, select the level of significance. So level of significance was 5%. Step 3, select the test statistics. So how we will select the test statistics? If this condition is met, then we will use the Z distribution. So what was the N? N was 2000 into 0.8. So which this value is definitely bigger than 5. So if I calculate this value, 2000 into 8, to 0.8. So this is going to be 1600. What is the value of variance? N into 1 minus population proportion. So this is going to be 2000 into 0.2. So variance is 400. So the condition is met, and now we are going to use the Z distribution, which is the normal approximation to binomial. So now we are going to formulate the decision rule. Reject H naught if Z is less than critical value. So this is the formula for critical value. Why we have the negative sign here? Because the rejection region is lie on the left side. So we are following the same procedure as we have followed in Z distribution example. This is this whole area under the curve is equal to 1. So this half is 0.5 and this half is 0.5. So we have subtract the 0.5 minus 0.05, which is equal to 0.4500. And we will see this value into the table and get the corresponding row value and the column value. So this is how we will check the Z critical value, which is minus 1.65. So this 1.65 will be 1.6 will be here and 5.05 will be on column. So the critical value, why we are having rejection region on a negative side, because of this inequality sign, which is suggesting that the estimated value is less than the critical value. So is the critical value is less than from estimated value. So the critical value is 1.65, which is greater than the 2.80. So it will be lie in the rejection region. Here we have the sample proportion. Proportion formula is P is equal to X over N. So X is 1550 divided by 2000. So the sample proportion is 0.75. So this is the 77 0.5% sample proportion. So we will get the value here. So the negative estimated value will be lie in the rejection region. I just noticed that the 1550 value was not mentioned in the question of slide. So it was mentioned in the book. So I just correct the statement of question in the slide. So let's get back to the example. So this information wasn't mentioned before. I just added this after noticing that the X value was missing. So now it's all set. So let's see what is the decision. Let's interpret the results. The computed value of Z is 2.80. So we are stating this value into the bracket, which means it's a negative value, is in the rejection region. So the null hypothesis is rejected at 5% level. The difference of 2.5 percentage points between the sample percentages. So what is the difference between which two values have a difference between the sample proportion and the population proportion? So this is the difference between these two, and this difference is basically called the sampling error. When there is a difference between population parameter and sample statistics. So this, that is called the sampling error. The evidence at this point does not support the claim that incumbent governor will return the governor's mention for another 4 years. So there is no chance to be re-elected as a governor. So this is the today's lecture, and I hope you guys are following the all recordings and with the book. So I'm expecting you guys are doing the relevant examples. And so this is it for today's lecture. In next lecture, we will see how to test hypothesis for the type 2 error. Thank you so much for today's lecture. Allah Hafiz. So now let's see how to deal with the type 2 error. Type 1 error is defined as a level of significance which is denoted by the alpha and the probability of rejecting the true null hypothesis. On the other hand, type 2 error is denoted by beta, and it's a probability of rejecting null hypothesis when it is false. So these two errors are actually trade-off to each other. With the larger sample size, the sampling distribution of the mean or proportion will be narrower. So if we have the larger sample size, so we can easily overcome these errors. So it also resulting the correct decision rule regarding the null hypothesis. Type 2 error example. A manufacturer purchases steel bar to make a quarter pins. Past experience indicates that the mean tensile strength of all incoming shipment is 10,000 psi. And the standard deviation is 400. In order to make decision about incoming shipment of steel bars, the manufacturer set up this rule for the quality control inspector to follow. Take the sample of 100 bars. So they will take a sample from the population, which will be the 100 bars at the 5 significance level. So this is the alpha, or you can say the type 1 error. Okay, then if the sample mean strength falls between 9,922 psi and 10,078 psi, except the lot, otherwise the lot is to be rejected. So these are two standpoints on the diagram. This is the mean population, which is mu. So we will see how to draw this information on a normal curve. Suppose the unknown population mean of an incoming lot, designated population mean is really 9,900 psi. What is the probability that the quality control inspector will fail to reject the shipment? So this statement is relevant to the type 2 error. So let's move on and see the difference between these two errors. So here is the illustration. We are saying alpha is divided by 2 on 2 standpoints each side. Alpha divided by 2. So on negative side, we have the smaller cut point. On the positive side, we had the greater cut point than the population mean. So the population mean was 10,000, which is stated at the middle of this diagram. And 9,922 is on negative side because it's lesser than 10,000. If I write this statement here, 9,922 is less than equal to 10,000. Is less than 10,000 is less than equal to 10,078. So this condition is actually followed over here. Simply the smaller side is on left and the larger side is on right. So here on region B, we have the type 2 error plotted on a normal curve. If the population mean is 9,900, then the type 2 error will be fall on the right side, because the standpoint of the acceptance of lot is 9,922, which is lesser than 9,900, sorry, greater than 9,900. 9,900, and this is the mu, and x bar is 9,922. So there is 22 pieces more. The probability of beta is 0.2912. So let's move on to the next slide and see the solution for this example. Number of standard units Z value between the mean of incoming lot is 9,900. So this is the formula which we are going to use for type 2 error. It's actually the same formula we have used before, but there is a different notation for just to make a difference. N is 100, sigma is 400, and the value of Z is 0.5. So how we get this value of Z is 0.5. So we put the value of sample mean, which is 9,922 minus population mean, which is 9,900, divided by 400 divided by under root n. So this is the standard error, and we calculate this value and we get the estimated value of C, which is 0.55. If we check this value into the Z table, we will get the value of 0.2088. So as you know that how we can check the Z value into the table, if we have a calculated value is 0.55. So we will see the 0.5 into the row, and column we will see 0.05. So we will get the value of 0.2088. So the area under the curve beyond the 9,922 pound is 0.5 minus 0.2088. So we need to find out the area. So what will be the shaded area? If I draw the normal curve here, and mu is 9,900, and X bar is 9,922. And after that, there will be a rejection region. The total area of this half is 0.5. And the calculated value is value of Z score is 0.2088. So we will subtract this value from 0.5 and then we will get the 0.2912. And this is the area of rejection region. So that value is actually stated in a previous illustration. So the probability of making the type 2 error is 29%. That is accepting an incoming lot of steel bars when the population mean is 9,900 psi. So this is the end of chapter 10. I hope you guys understand all the concepts. If you don't, or you have and facing any difficulty while solving the questions, you can ask anytime. Thank you so much. Allah Hafiz.